Hello kids. In the next 3 videos, I'd like to discuss the exponential function and its graph. In today's video, I'd like to discuss the parent function and the parent graph. A function of the form y is equal to b to the power of x, where b, the parameter, is a positive number not equal to 1, is called an exponential function. Now, an exponential function comes in 2 types, an increasing and a decreasing type. Now, the type of an exponential function depends on the value of b. If b is a number greater than 1, for example, if b is 3 and our function is y is equal to 3 to the power of x, that exponential function is an increasing function, which means as the value of x increases, the value of y also increases. For example, when x is equal to 1, we'll have 3 to the power of 1 is equal to 3. But when x is equal to 2, 3 to the power of 2 is equal to 9. So the value of y went from 3 to 9. It increased, so we call the function an increasing function. On the other hand, if the value of b is less than 1, for example, if b is 1/2 and our function is y is equal to 1/2 to the power of x, that function is a decreasing function. The value of y decreases as x gets bigger. Now, we will see an example of each type in the next 2 videos. So at this point, I don't want to get into the, the values of y as x changes too much, but we'll just remember that when b is greater than 1, we have an increasing function, and when b is less than 1, we have a decreasing function. Now, the graph of an exponential function is called an exponential curve. When b is greater than 1, we get a curve that rises as we go from left to right. And if b is less than 1, we get a curve that falls as we go from left to right. Now, both graphs have a lot in common, and they have a few differences. Let's talk about what's common between the two. What's common is that both graphs cover the entire x-axis as we go from left to right. That means that the domain of an exponential function is all real numbers. Again, that means that you can use any input you like to use as x. You can use positive integers like 1, 3, 5, 6. You can use negative integers like -2, -3. You can use fractions like 1/2, -1/2. Or you can use irrational numbers like radical 5 and negative radical 3. The domain of an exponential function is all real numbers. But as you can notice, both curves are above the x-axis. That means the values of y can only be positive, which means, again, that the range of an exponential function is only the positive values of positive real numbers. So, the domain of an exponential function is the set of all reals. The range of an exponential function is only the positive reals. Both curves we talked about how they're never below the x-axis. In fact, they never touch the x-axis. There's no intersection between the curve, exponential curve, and the x-axis. That means there are no x-intercepts. No x-intercepts for the graph of an exponential, unless, of course, there is a translation, which we'll again talk about in future videos. But the parent graph has no intersection with the x-axis, no x-intercepts. There is one intersection with the y-axis though, so we do have a y-intercept. Both y-intercepts are y is equal to 1. So the exponential curve intersects the y-axis at the point 0, 1. The end behavior for these two are exactly opposite of each other. So it's the same idea, but opposite, exactly the other way around. What do I mean by that? Notice on the right-hand side, this curve moves and goes up without bound. Well, that happens on the left side of this curve. The curve goes up without bound. Now, what does that mean? That means as x gets bigger, as the value of x increases, the value of y increases without bound. Mathematically, we say as x approaches infinity, y approaches infinity. That's called the right-end behavior. We're on the right side and we're talking about the end behavior. What happens at the end of the line here? All right. So the right-end behavior of an exponential function is infinite. In fact, it's positive infinity. Now, for this curve, that happens on the left side. So how do we say that? We say as x approaches negative infinity. As we travel along the x-axis and we go way to the left, the curve goes up. That means the value of y gets bigger and bigger. So the left-end behavior of an exponential function when b is less than 1 is infinite, in fact, positive infinity. Now, what happens on the opposite side? Well, with this curve, on the opposite end, that means on the left side, the curve gets closer and closer to the x-axis. That means as x goes toward negative infinity, the values of y get closer and closer to 0. We never touch the x-axis, so the value never is 0, but it gets closer and closer to 0. So the left-end behavior of an exponential function where b is greater than 1 is 0. Now likewise, in this graph, that phenomena happens on the right side. So as we travel to the right, the curve gets closer and closer to the x-axis, so we say the right-end behavior of this exponential function is 0. So to put that together, this is the left-end behavior. How do I know it's the left-end behavior? Because I'm saying as x approaches negative infinity. Now, what I've written in red is the actual behavior. So the bottom line talks about the location. The top line tells me what the behavior is. So when I see x approaching infinity, that means the discussion is about the right-end behavior. And then the behavior is written on top there. Sticking with the idea of growing without bound is the discussion for maximum and minimum values of a function. Well, since both of these curves, this curve on the right side and this curve on the left side, go up without bound, that means we have no maximum value for the function. So an exponential function has no maximum value. And we don't have a minimum value either, because the curve gets closer and closer to 0, but it never actually hits 0. If it ever hit 0, then we'd say the minimum value is 0, but it doesn't hit it. So what is the minimum value? Well, is it 0.1? No. Go further along, it can be 0.01 or 0.001. An exponential function has no minimum value. So no minimum, no maximum. The idea that the curve gets closer and closer to the x-axis but doesn't touch it creates an asymptote. An asymptote is a line that a graph gets closer to but does not touch. In this case, the x-axis is an asymptote. And since it's a horizontal line, we call it a horizontal asymptote. So the exponential graph has a horizontal asymptote, and it's the x-axis. When we discuss functions, we always want to know whether that function has an inverse or not. It's really important to identify a function that's invertible. It means a function that has an inverse, or a function that's non-invertible. That means a function that doesn't have an inverse. Well, how do we check to see whether a function is invertible or not? Well, if a function is 1-to-1, that function is invertible. That means it has an inverse. Well, how do I check to see whether a function is one-to-one or not? Well, we can look at the graph and see whether the graph passes the horizontal line test or not. What is a horizontal line test? It's a test where you draw a horizontal line anywhere on the graph, right? And see whether that line intersects the graph in more than one place or not. If you're able to draw a line, horizontal line, anywhere on the graph and only have one intersection, then your graph passes the horizontal line test, which means your function is one-to-one, which in turn means your function is invertible. It has an inverse. Now, the inverse of an exponential function is the logarithmic function, which comes up in future videos. So, wrapping this up, we discussed what an exponential function is. It's in the form y is equal to b to the power of x, where b is a number positive, not equal to 1. The domain of an exponential function is all real numbers. That means any input is allowed. But the range is only the set of positive reals. That means the outputs of an exponential function always positive. The exponential function is increasing if b is greater than 1, decreasing when b is less than 1. In fact, the number b in applications is called a factor. In this case, it's a growth factor. In this case, a decay factor. Growth factor, decay factor. There is an asymptote. The x-axis is the asymptote. The equation for an x-axis is y is equal to 0. And this asymptote is horizontal. The exponential function is one-to-one. That means we have an inverse. So it's an invertible function. There is no maximum and there is no minimum to an exponential function. The value of y can be as big as you want it to be, and it can be as small as you want it to be. Next time, we'll discuss the function y is equal to 3 to the power of x, make a table of values for it, and graph it. And likewise, we'll do that in another video for the function y is equal to 1/2 to the power of x. Until then, goodbye.